Alright, in this video, we'll be studying positive regulation. So in the system, there's no glucose. That's step 1. So when there's no glucose, we go to step 2. There's an increase in cAMP. Now cAMP is cyclic adenosine monophosphate. 3, cAMP then binds to CAP at the allosteric site. Now CAP is catabolic activator protein. Now once these two bind, this complex will then bind to the promoter site of the lac aperon. So they're binding. Now, once this complex is bound to the promoter, the RNA polymerase can then bind to the promoter and begin transcription. Alright, welcome to the study time portion of the video. So how are we going to remember this? Well, I have 1, 2, 3, 4, 5 steps that you have to remember for positive regulation. So 1, when there is no glucose in the system, there is an increase in cAMP. This will give us the opportunity to have cAMP bind with CAP at the allosteric site of the CAP. Once they bind together, they have the ability to bind to the promoter site of the lac operon. Once that occurs, the RNA polymerase can then bind to the promoter and start transcription. All right, let's try this again. No glucose, there's an increase of cAMP. CAP can then bind with the cAMP at the allosteric site of the CAP. This complex will then bind to the promoter of the lac operon, which in turn will allow the RNA polymerase to bind to the promoter to start transcription. No glucose, increase in cAMP. We have our CAP and CAP complex at the allosteric site of the CAP. They bind to the promoter. In turn, the RNA polymerase binds to the promoter to start transcription. So it's the test your knowledge time for the positive regulation. So we have steps 1 through 5, and we're going to go through these and see if you have learned positive regulation. So here we have step 1. In this system, there is no what? 2, there is an increase of what? 3, a complex is formed. What is the name of that complex? What's included in that complex? Now this complex then binds to what on the lac operon? And what polymerase binds to this part of the lac operon? After this polymerase binds to this part of the lac operon, what happens?